Last class, we worked with proving the Pythagorean theorem. Since we've now proven it, we can use it, right? Whew, about time. So let's first put in the Pythagorean theorem as a rule, give it a context. What's it used for? It's used for finding missing sides of what kind of triangle? Right. It has to be a right triangle. And usually in terms of terminology, A and B are called legs. And C is called the what? Yes, the hypotenuse. So once we establish that this is called a leg, this is called a leg, and this is called the hypotenuse, please be quiet. What we want to do is create the rule. And rather than saying for any right triangle, which doesn't specify A, B, and C, I suggest we draw a little picture of a right triangle, clarifying that the legs are A and B with the hypotenuse C. And that given this hypothesis, the conclusion is that A squared plus B squared equals C squared. And the Pythagorean theorem must contain both parts, the hypothesis and the conclusion. Please don't just say it's A squared plus B squared equals C squared. Now you've had a chance to practice this, but let's do a couple here just to ensure everybody's got it. How should I set this up? Question one, is this appropriate for using the Pythagorean theorem? Does it have a right angle? Does it have two sides given to me and one side we're looking for? Yeah, this looks like a good choice. So how do I know which one's C? Because that's going to be unique, right? It's the hypotenuse, the longest one, right? So in this case, it's going to be 8 squared plus 13 squared equals x squared. And then we could solve that out. What about number 3? How do I set this one up? Yeah, Lillian, go ahead.
X squared plus 7 squared equals x.
Good. This time it's different, right? Because the one that's missing is one of the legs rather than one of the, or rather than the hypotenuse. So this time I'd say x squared plus 49 equals 81. Subtract 49 and get x squared equals 32. Now what? Okay, square root both sides. I get x is equal to square root of 32. Am I done? No, what can I do here? I can simplify that radical. I can take the number 32 and factor it. What does 32 factor into? 16 and 2 works. 8 and 4 would have been good. Once I get 16 and 2, 2 is a prime number, so I leave that one alone. Can I take 16 further? 4 and 4. Good. Now, in fact, I could take these all the way to primes, or because they pair up and there's only one number left, I can actually treat this as square root of 4 times 2. I see that the 4s pair up, leaving the 2 on the inside. And so this is 4 square root of 2. That's the finalized simplified answer, although this particular worksheet does say round to the nearest 10th. So I'm going to take my calculator and say, tell me what 4 times the square root of 2 is. And that gives me a decimal approximation, 5.656. So that's round the nearest 10th, 5.7. So I'll put the squiggly equal sign, 5.7. It's approximately equal to that much. Any questions on the basics of finding a missing side using the Pythagorean theorem? Okay, there are some harder ones on here, and you're going to have some time in class to work on these. I'll give you number 6 here a little bit. What's wrong with this? Yeah, it's not a right triangle that we're dealing with, is it? We can only use Pythagorean theorem if we have a right triangle. Therefore, we have to make a right triangle out of this. Well, this side looks like it could be a hypotenuse, doesn't it? But I know, like if I did it this way to make the right angle, that's not going to work. But what if I were to do this? Draw a line right there, and I'm going to force it to be a right angle here. That means it's a right angle here. And if I've got a quadrilateral in here with 3 right angles, what's true about this one? It's also a right angle, which means this quadrilateral in here that I've shaded in is what kind of shape?
Rectangle.
Rectangle. We know a rectangle is a parallelogram, therefore opposite sides are congruent. If this side is 5, so is this side. And if this side is x, so is this side. Therefore, I can use this to find the missing part here because I know the hypotenuse is 16. I know that this side is missing. How long is this side? 13, because it's all of the 18 less that 5. So then I could say x squared plus 13 squared is equal to 16 squared and go through the process. Okay. All right. You'll have some opportunities to practice with these. I want you to engage with each other and discuss, be as precise as you can, and simplify all radicals. Now we come to the meat of today. That's just a little practice on stuff you should already know how to do. Now, I know that the vogue thing is to talk about everybody's special and everybody's just as good and blah, blah, blah. But I got to tell you, there are 2 right triangles that are more special than any others. These are called special right triangles. And everyone else is jealous of them, I know. But you'll see in a moment why they're special. Pythagorean theorem allows us to find one missing side if we're given 2 other sides. Do we agree that Pythagorean theorem doesn't do us any good if I know that this is 5 and that's all? Doesn't help. What is that? I can't see what that is. So we understand that if I have a triangle with one side given, even if it's a right triangle, I can't use Pythagorean theorem to find both of these because it's 2 missing sides. So that doesn't help me at all. But these special right triangles will help us under certain circumstances. First one I want to talk about is what happens if you take a square. So by definition, it's got 4 right angles. It's a rectangle. And it's got 4 congruent sides. It's a rhombus. What if I then slice this in half with a diagonal? There's the triangle I'm talking about. Do you know what the angles are in that triangle? They both have to be 45, don't they? Because if it's isosceles, which it is, then these base angles are the same. All the angles in a triangle add up to 180. We know there's a right angle, so we can subtract that. There's 90 degrees left to be evenly split. 90 divided by 2 is 45 degrees. So this is a 45, 45, 90 triangle. That's what we call it. Now, what about the side lengths here? Let's say that this side length is 10. How long is this side length? Also 10, right? How long is the hypotenuse? We have to find it. Can we use Pythagorean theorem now? Sure, we got 2 sides. We can find this. So let's call it x. 10 squared plus 10 squared equals x squared. 100 plus 100 equals x squared. 200 equals x squared. X equals root 200, which is 2 times 10 times 10. So it's 10 root 2. We agree? Now, what if I had a different 45, 45, 90 triangle and this were 5 and this were 5? How big would this be? So it'd be 25 plus 25 equals x squared. 50 equals x squared. X equals root 50, which is 5 times 5 times 2. 5 root 2. Agreed? Notice I'm not turning them into decimal equivalents. When the side lengths are 10, the hypotenuse is 10 root 2. When the side lengths are 5, the hypotenuse is 5 root 2. Anyone have a conjecture they think might be true?
the same, and that means that it'll be like outside of the square root, the same number outside of the square root.
Okay, good. See if we can prove that. If we make a 45, 45, 90 triangle, and we call this side A, how long is this side? It's got to be just A as well, doesn't it? Because if it's isosceles, base angles are congruent, then these sides are the same. And if we're looking for X, we'd say that A squared plus A squared equals X squared. If I have one A squared and the second one, that gives me two A squareds. And if I want to solve for X, I'm going to square root both sides. On this side, I get X. On this side, I get square root of 2 times A times A. Who's pairing up? A. So that comes out as a single A, and I get A root 2 is equal to X. So that is going to work. Take a look at the worksheet you got in front of you. What this says is that for a 45, 45, 90 triangle, if your leg is equal to A, then so is the other leg. And how big will the hypotenuse be? A root 2. So what's that going to look like here? Well, we've got a side length of 8. How long is X? 8. And how long is Y? 8 root 2. Easy peasy. Please do number 2 yourselves. Just stick a root 2 on it. We like this, right? Okay. Just a second. All right. So did we finish this up? What did we get for Y? Yep. And X? Now, what about 3 here? This one's a little, you know, the hypotenuse. You don't have A or B, but whatever they are, when you multiply them by root 2, it's going to equal 19, isn't it? So in other words, this 19, if this is X, we can think about this as X also, right? And this would be then X root 2, wouldn't it? So I'm going to take that. I'm going to say X root 2 is equal to 19 in this problem. I want to solve for X. It's being multiplied by root 2, so I divide by root 2. That means X equals 19 over root 2. Does that make sense that if I were to multiply this side, 19 over root 2, by root 2, it would give me 19? Yeah, if I multiply this by root 2, they cancel and it would give me 19. So it's the right answer, but are we allowed to leave it like this? No. We got to simplify it by putting a root 2 on top and a root 2 on bottom. So we're multiplying it by a version of 1. We're going to get 19 root 2 on top. And root 2 times root 2 is root 4, which comes out to be a regular 2. So the side length is 19 root 2 over 2. We don't like this one quite as much, do we? It's a little harder. But what I'm going to do, we've already got a formula up here. If we know the side lengths of AA, just stick a root 2 on it. Let's do the same idea over here for the opposite style. In other words, if we have a side length here of A for 45, 45, 90, then these legs are going to be that divided by root 2, which simplifies to A root 2 over 2. And the same here. If you know the hypotenuse, these are just going to be that over 2 times root 2. Any questions on 45, 45, 90 triangles to find missing legs?
Can you just show number 3?
All good? So the other version we're going to be looking at is a triangle called a 30, 60, 90 triangle. So here's the 30, here's the 60, here's the 90. Remember last time how we took a square, an equilateral quadrilateral, and sliced it in half? getting our triangle. So if I folded this over this way, I'd get a rectangle, but that doesn't help me much. It's not equilateral. But what if I go down this way? If I copy this exact triangle and flip it over here, if this is 60, then this is 60. If this is 30, then this is 30. What kind of triangle am I making? Just isosceles? 60, 60, how big is this angle? 60, 60, 60. This is equilateral, which means if I know this side is 10, how long is this side? How long is this whole side? But how long is this little part? 5. Because of that warm-up thing we did, right? An isosceles triangle, the altitude is bisecting the base. Yep.
So you just, so you actually just like go to 69, you just draw another triangle to find one of the sides.
I'm going to derive that formula. Gentlemen, please stop talking. It is disruptive. I'm going to use this picture I've just drawn you to derive a formula that you'll be able to use easier. You won't have to derive it every time because once you know the formula, you can just apply it. Now we've got a right triangle with this base as 5, this hypotenuse as twice as much, 10. We need to find this one. So I'm going to say 5 squared plus x squared equals 10 squared. 25 plus x squared equals 100. Subtract 25, x squared is 75, which means x equals square root of 75. And again, I'm going to simplify this rather than get a decimal equivalent. What pairs up? So in other words, this is 5 root 3. What I'm getting is that when this base is 5, this thing will always be twice it because this times 2 is the full length. And if this is always twice it, when I square it, it's going to be like 4 times as much. When I subtract one more, I'm going to be 3 times as much. This side will always be 5 root 3 or 3 root 3 or whatever it is. So here's our rule for that. If I've got a 30, 60, 90 triangle, and the shortest leg opposite the 30 is A, then the hypotenuse will be double that, 2 times A. And this longer leg will be that A times the square root of 3 this time. So let's take a look at number 4. This is the shortest leg of 5. So how long is the hypotenuse? 2 times that is 10. And how long is the longer leg? 5 root 3. Just stick a root 3 on it. Okay, what about number 5? The shortest leg is 14. So how long is the hypotenuse? 28. And what about this side? 14 root 3. Okay, let's throw a twist at you here, number 6. Now the hypotenuse is 32. So how big is x? Good. And if x is 16, how big is y? Very good. You guys getting this? What about number 9? Good. X is going to be 9 because that's the smallest side. This other leg would be 9 root 3, which it is, and the hypotenuse would be 18. Now, what about number 8? This is like that other one we had a hard time with, isn't it? Number 3. If we knew y, could we find x? No problem, that's just double. And if we knew x, we could find y, that's no problem. And if we knew y, we could find this one that's marked as 20, but going from 20 back is harder. If we knew y, what would we do to get to 20? what goes here? You'd multiply it times √3. So if we want to go backwards, what do? Yeah, so this side is going to be 20 divided by √3. Now, unfortunately, that's not simplified, is it? I'm not allowed to have a square root in the denominator. I multiply by √3 over √3, a version of 1. So I'm not changing its value. And that gives me 20 √3 over √3 times √3, which is √9, or they pair up, giving me a 3. So 20 √3 over 3. So that's y, 20 √3 over 3. And what would x be? Good, it's just double that, 40 √3 over 3. And just like we did before, over here, let's give ourselves a rule or a little formula for when we're dealing with a 30, 60, 90 triangle. And we're given the not the hypotenuse, right? Well, we'll come back to that. When we're given this side, the one opposite 60 as A, this one would then be that number times √3 divided by 3. So A √3 over 3. And then the hypotenuse would be 2A √3 over 3. Kind of an ugly number or a beautiful number, depending on how you perceive math, right? Okay, for the rest of class, please finish up this 4-sided worksheet. In the event that you have not taken all your test options and you'd like to take your test option, please come on up to me and give me your phone, and you can do that during this period.